Hi, and thanks for watching this video, which is an update on high resolution graphics on my homebrew computer. So last year I showed how we can poke the VDP directly to access high resolution pixels, but that's really slow. So what I've decided to do is add native commands to my interpreter called dflat, so that we can do high resolution lines and points much faster. So I'd like to show an example of what we can do now with that. I've got a couple of examples. The first one is called Stitch, which takes me back actually to when I was first learning to program, and I remember on the Oric 1 this was a program very similar to this was provided, which I typed in, and essentially it draws a number of straight lines offset from each other to create this effect of a curve. The interesting thing here though is how do we draw straight lines? It's actually not that easy to do when you've got a processor that doesn't have floating point capability nor multiply or divide capabilities. The algorithm that comes to the rescue here is called Bresenham's line drawing algorithm, which was invented in the 60s for precisely this kind of application, i.e. low power microprocessors, which in the 60s, of course, floating point wasn't that common either. So this is ideal for implementing on a 6502, where I've only got shift left or shift right to do multiply and divide by 2, and integer addition and subtraction. And I might do a video on Bresenham's line drawing algorithm in the near future, actually, because the other ones I've seen on YouTube seem to talk about the equation of a line and y equals mx plus c, and then from there still keep the algorithm using floating points, which is really missing the purpose of the original reason why the Bresenham algorithm was so useful, because of precisely this lack of floating point capabilities in the processors of the day, and then in low cost processors like the 6502 in the late 70s and 80s. So maybe we'll do that in the near future. But I want to show another example then of what this what the capabilities are of these new commands. So this next demo is basically plotting a curve stitching square like you've just seen, but erasing the previous one, so you get the effect of an animation. So this is the width of the square, this is the step size, and this is the delay between frames, and this is the output. So because the square, or the lines anyway, are 100 pixels each, then that means we're basically drawing 400 pixels roughly per frame, but we're also erasing 400 pixels per frame, so essentially 800 pixels for every frame of animation that we can see. And I don't think it's too bad actually, so I'm quite pleased with the performance, which probably is good enough for me to be able to write a simple lunar lander type game to simulate those vector graphic types games of the late 70s and early 80s using just dflat. So I may also have a go at that. But thank you for watching my video, and hope that was useful.